Why does the brain show cross-modal plasticity in blind people? Imagine a brain that can rewire itself like a flexible road map, changing routes to keep everything moving smoothly. That's what happens in the brains of people who are blind from birth or early childhood. When the eyes don't send visual signals, the brain doesn't just sit idle. Instead, it reorganizes, using the areas usually dedicated to seeing four other senses like hearing and touch. This process is called cross-modal plasticity, and it shows how adaptable our brains truly are. During early development, the brain is especially open to change. This period is like a window where neural circuits are still forming and can be shaped by experiences. If vision is missing during this time, the brain doesn't leave the visual areas unused. Instead, it recruits those regions to process sounds or tactile information. For example, the part of the brain that normally detects motion visually can start to interpret sounds that move or change. This makes sense because the brain is organized by what it does, not just by what senses it receives. This idea is called the metamodal organization of the brain, meaning certain areas are wired for specific tasks, regardless of the input source. The strongest changes happen during early childhood, when the brain is most flexible. If someone loses their sight early on, their visual cortex, which is in the back part of the brain called the occipital lobe, begins to connect more with auditory and touch processing areas. Brain scans show that pathways between these regions become more active and better connected. White matter, which is like the wiring of the brain, also changes to support these new connections. These adaptations help the brain make the most of the remaining senses. Some of these changes happen because existing neural pathways that connect different senses are usually quiet in sighted people. When vision is lost, these pathways become stronger and more active. It's like turning up the volume on a speaker that was previously muted. Additionally, subcortical structures like the thalamus and superior colliculus, which relay and process sensory information, also change. For example, auditory signals might reroute through the visual parts of the brain, allowing sounds to be processed in areas normally reserved for vision. This ability of the brain to reorganize itself is especially important during early childhood. When a child is born blind, their brain adapts by reallocating resources to enhance other senses. This makes them often more sensitive to sounds and touch, which helps them learn and navigate their environment more effectively. It's like the brain is compensating for the missing sense by boosting the others. Understanding this process highlights why early intervention matters. Providing rich auditory and tactile experiences to young children with visual impairments can help strengthen these new connections. It supports their development and helps them become more skilled at using their remaining senses. In summary, the brain shows cross-modal plasticity in blind people because, when visual input is absent early in life, the brain reorganizes itself. It recruits the visual areas to process other sensory information, making the most of what remains. This flexibility during early childhood allows individuals to adapt and develop heightened abilities in hearing and touch, showing just how adaptable our brains can be.